Good morning, good evening, or good afternoon. This is a full paper work through of the June 2018 2H paper. Now, this is mostly a blind work through. I haven't prepared or looked through this paper beforehand, so it should give you some of the good insights, ideas, and a blank look at a new paper. Do feel free to pause, rewind, etc. as we go through. And we'll start with our humorous name. We're going to be Ed Excel. And we'll jump straight into it. Formula page as normal. Refer back to it if there's any of these that you're not sure that you've remembered correctly. A very helpful page. And straight into question 1. We're starting with some core algebra. Make A the subject, so we want to rearrange to get A all on its own. So let's start by moving the BD, and then let's divide by the C. Solve the inequality. Let's add the 4. And solving inequalities just like solving an equality, except the symbol in the middle is different, provided you're not timesing or dividing by a negative number. And finally, on the first page, let's factorize. The number that goes into both is a 6. We have an e squared in both and an f. The first term, we need 3 and an extra 2 f's. The second, we need a 2 and just an extra e to make everything match up. Question 2. Work out the difference between the largest and the smallest share when 3,450 yen is divided in the ratio. Okay, so our total here is 15. So 15 parts is this 3,450. And dividing through by 15 tells us that 1 part is worth 230. So we can now turn this ratio into actual yen. So 2 lots of 230, 6 lots of 230, and 7 lots of gives as so. Now, what did the question want? It wanted the difference between the largest and the smallest. So the difference we want is 1610 minus 460, giving us an answer of 1,150 yen. More international currencies. We have 2 individuals being paid. They're both given an increase in their monthly pay. They are paid the same amount afterwards. Okay, so let's work out what that shared new pay is going to be. So we have the first character as 20,000. An increase is a 1.08 multiplier. So that 20,000 multiplied by 1.08 gives the new shared salary of 21,600. And then we want the percentage increase. Well, the formula for percentage change is the change over the original times 100. So the change is 21,600 minus the 19,200 over the original, which is the 19,200, times by 100. So typing that carefully into our calculators is giving us a percentage change of 12.5%, which does make sense. They started with less money, so they needed a greater percentage increase to get to the same amount. Unusual for this to be question 4. Almost always this is question 1, but a show that with fractions. Step 1, let's make things mixed. The 7 times the 3 plus the 4 makes that 25 over 7. Minus, same again, 1 times the 8 plus the 5. Now I'm not going to put this equal to that answer because I'm trying to aim for that. So if I continue from here, well, the only choice is to make a common denominator. So I've times the first one, the bottom by 8, so the top by 8. And the second one, bottom by 7, so top by 7. So that's giving me 109 over 56. And if I take off, well, 56 goes into 109 once, with 53 left over. A lot of working space as well for that question, but that's all they're expecting of you. Question 5, are circle theorems. In the diagram, P and Q are points of a circle with centre, QT is a tangent, and OPQ is 18. We want PQT, so we're looking for this angle here. Don't be tempted to use alternate segment. Alternate segment requires all parts of that triangle to go to the edge of the circle. So those two angles would be the same, not the 18 and the angle shown. But we can say that this angle here is 18. So PQO is 18 as OPQ is an isosceles. And I'm going to give a reason within my reason, as it is made from 2 radii. OP and OQ are both the radius of the circle, so have to be the same length. Okay, so now we've got that being 18, we can now state that OQT is 90 degrees as angle between a radius and tangent is 90. Well, then we're basically home and dry. Then PQT is 90 minus the 18 is 72 degrees. Only 3 marks, so it's just quite harsh for needing 2 reasons, but there wasn't particularly anything deep. They were fairly simple circle theorems that we applied. Question 6. Straight away I'm thinking this is a similarity question. So I've got 2 cylinders. Cylinder A has some dimensions. Work out the curved surface area of cylinder A. So it's not immediately similarity. So curved surface area formula is 2 pi RH. That's on that formula page. Do flick back and check. So that's 2 pi times the radius, which is 0.56 times the height. And the question does want our answer to 3 sig fig. So I'm going to type it into my calculator. Some of your calculators may have given it in terms of pi. I'm then going to turn that into a decimal, write it out once with a little bit more accuracy before I round it, just in case I do make some kind of calculator typo or just rounding typo. They can still give me the marks. Cylinder B is mathematically similar to A. There's the similarity. Height of cylinder B is 0.6. Work out the radius. So we need our scale factor. I always do my scale factor as big over small. So the scale factor, and here I definitely want to be leaving that as a fraction rather than rounding it and losing accuracy because of rounding. And then we want the radius of B. So the radius of B is then, well, it's the radius of A. And because I'm going to the smaller one, I'm going to divide Now you can even use the answer button in your calculator to not need to type in that again. 0.21 seems reasonable compared to the other lengths in the picture. Question 7. We have 2 classes taking the same exam. There are various students in each class. We've been given some means and we want to work out the other missing mean. Okay, lots of ways to tackle this. Maybe the simplest is to set up a little table. So let's have class A and class B, and then let's have the number of students and the total mark and the mean. We also need them combined together. Now you could of course do this question without one of these huge tables. I think it just summarizes the data really nicely. So we were told there are 28 in class A, 32 in class B, which means there are 60 students in total. The mean for both classes combined is 72.6, and the mean for class A is 75, and I'm aiming for the mean of class B, which is that box there. So let's go and work out some total marks. So the total mark for all the students, remembering that the mean is the total divided by how many. So if I do the mean multiplied by how many, I can go back to the total marks. So the total marks scored in both classes was that. We can go back here by times it by 28. So class A scored 2,100 of those marks. So class B, if I do a subtraction there, scored 2,256. Now going to the mean, we're now going our forward mean calculation. So we're dividing by 32, giving a mean of 70.5 for class B. Again, worth just thinking, does that seem reasonable? Yes, it appears class A did better than the average, so class B had to have done worse. Carrying on with these same 2 classes, class A, the lowest score was 39 and the range was 57. Okay, so again, I'm going to set this up as a little table. I'm going to have class A and class B. I'm going to have the lowest, highest, and the range. So class A, the lowest was 39 and the range was 57. So if I want the highest, I can do 57 plus the 39. So the highest score in class A was 96. Now in class B, the lowest was 33, the range was 60. So the highest 33 plus 60. But now if I combine them, then I have to use the lowest overall and the highest overall. So we're using those 2 figures. So now the range is the difference between those is 63. When you combine the results together, your range tends to increase, whereas your mean or your averages kind of go towards the middle of any input data. Question 8. This feels a bit odd because we've had a couple of difficult problem solving questions in a row now, and now question 8 goes back to a simple version of a nice topic. This is our trig question. We have the A, we want the H, so we're thinking K. So cos 52 is the adjacent over the hypotenuse. I should probably call that X instead, as that's what's labelled in the picture. So X, if we rearrange this, times up by the X, divide by the cos 52, and typing that into our calculator, we get 20.46, etc. It wants it to 3 sig fig, so that's 20.5. Again, just feels a bit odd that we've had two problem solving followed by fairly straightforward. And we have another fairly straightforward straight after. Solve the simultaneous equations. So we need to make either the x's or y's match. I'm going to times the top one by 5 to make the y's match. If I have a choice, I tend to try and make the thing with the opposite signs match up. So I could have times the top one by 7, but then I have the same sign, which means I subtract. Subtracting causes just one or two more errors. Here, my y's are the same but opposite sign, so I can add. Adding is much less likely to cause many errors. The 78 divided by the 12 gives me my x to be 6.5. Then the first equation is telling me that x plus y is 15, so the y has to be 8.5. And I'll put them on the answer line. Of course, a really good hint is then to check that that is correct. So I'm going to go back to the second one and just make sure that it works in my calculator. 7 times 6.5 minus 5 times 8.5 does indeed give 3. So I know I've done that question right. Question 10. Laws of indices. But the first thing to notice is 8 and 2 do not match. So I need to rewrite 8 as 2 cubed. And then that division means we subtract the powers. So this thing is 2 to the negative 4. 3 subtract 7. So the n is just negative 4. I would argue a simpler question next, even though it's going to require 2 steps. Power to a power, multiply the powers. And then multiplying, we add the powers. So I get k as negative 19. I would not suggest that you try and type any of those in your calculator. This thing is going to be so close to 0 that your calculator may, well actually even this, the 3 to the negative 19 is going to be basically 0 in your calculators. So it's not really going to hold enough information if you've forgotten the laws. Question 11. Solid metal sphere of radius and mass, work out the density. So we need to remember our density formula. The way I remember it is dmv as a little formula triangle. So I want to do the mass divided by the volume. I don't have the volume yet, but I do know it's a sphere and I know its radius. So again, looking at that front page, inside front cover from your formula book, the volume of a sphere is given by 4/3 pi r cubed. So typing that into my calculator, and I could work out as a decimal, but because I'm in the middle of my working, I am going to leave it exact. So that's my volume. I actually wanted my density, which is the mass divided by my volume. And I'm going to again use the answer button on my calculator, so I don't need to retype anything in and potentially make extra errors in that way. Give more accuracy than the examiner wants, and then round it onto the answer line. 7.75. Question 12. We must be getting close now to the middle of the paper, so we're starting to expect both harder topics and the questions to be asked in a slightly harder way. And straight away, this one, although it's on a simple topic of just angles, does look like it's been asked in a difficult way. This shape is not a pleasant one. We have a hexagon. BC is parallel to ED, and work out the angle DEF. Now it does want the obtuse angle. So the final answer I'm giving is going to be this side here. What I've labelled in blue is a reflex angle, not an obtuse. So I need to remember that when I come to the end of the question. Nice thing is we've got a lot of labelled angles, but we don't quite have enough labelled angles. But I can see that we have, with my parallel lines, a C shape here. So that tells me those two angles add to 180. So EDC is going to be 180 minus the 42 is 138. Question doesn't ask for it. But if it did, the reason would be that co-interior add to 180. Okay, so now I have all but one angle in this hexagon. So let's use our internal angle, or interior, sorry, angle formulas. So the total interior of a hexagon, unfortunately this is a formula that you have to memorize, is n minus 2 times 180, here n being 6 for the 6-sided hexagon. So the total angle is 720. So what do we have so far? So far our angles are 50, 96, 144, 42 and the 138 we've just worked out. If we total those, we then can work out how much is left over. That's a fairly small number. I was expecting slightly greater, but this is a reflex angle, so maybe fine. So the reflex FED or DEF is 720 minus the 470. 720 minus 470 gives a reflex as 250. Now that is a reasonable sized reflex angle, but of course that's not what the question asked for. So the obtuse, I'm going to write it the letters the same way around as they did this time, is the leftover around a point. So that is 110, which does look reasonable for how the picture is drawn. It isn't drawn accurately, but it does give you a bit of a hint that this angle indeed is, well, the question said it was reflex, but it's not that much more than a right angle. So 110 seems very reasonable. Question 13, a big tree diagram. Felix has 10 cards of various different colours. He takes at random one of the cards he does not replace. Okay, so that means the probabilities on the second set will be different. And then he takes the second card. So if he took a red one to start with, we now only have 4 red left. There are only 9 left in the pack. If we took a red first, we still have 4 blue, and we still have 1 green. So those two didn't change. If instead we took a blue with our first pick, then the red and the green didn't change. Of course, they're now out of 9 because I did take a card out. And the blue went from 4 blue down to 3 blue. And finally, if I took a green out, the red and the blue still have their original amounts. But now there are no green cards left, so that's 0 or 0 out of 9. A good thing to check is that at every split, your probabilities add up to a whole, basically add up to 9 out of 9, which indeed each of those splits do. Work out the probability that Phoenix takes at least 1 blue and no green. So we need to now think about our picture and pick out how could I get at least 1 blue and no green. Well, I could go red, blue. I could go blue, red. That gives me 1 blue. But I could have had at least 1 blue. So I could have gone blue, blue. But I'm not allowed blue, green or green, blue because we didn't want a green card. So we need those combinations. When you go through the tree diagram, you multiply. So red, blue is the 5/10 times 4/9. The blue, red, 4/10 times 5/9. And the blue, blue, 4/10 times 3/9. And totaling all of those up, I think is 52 over 90. I've just multiplied the tops and then added them together. I am going to use the calculator to simplify, because that definitely is a fraction that simplifies, although not particularly excitingly. 26 over 45. Nice tree diagram question, despite being a 3 tree. Moving on. A plotting question. Quite late in the paper for a plotting, but it is quite an unpleasant cubic. So we need to sub our values in, being exceptionally careful with the negatives. Whenever you sub a negative into pretty much anything, you should, by habit, putting brackets round each and every time you sub it in. So negative 2 cubed minus the 2 times negative 2 squared minus 3 times negative 2 plus 4 gives me negative 6. If I do the same for negative 1, I won't write out all my working, but you can imagine each of those negative 2's now just being a negative 1. I even in my calculator didn't type all out. Again, I just used the arrow keys to change the 2's into 1's. And then subbing in 1, again use the arrow keys to delete all the negatives. Next, we need to do 2 cubed minus 2 times 2 squared. Typing the wrong parts into my calculator. Minus 2 times 2 squared minus 3 times 2 plus 4 gives negative 2. And if I sub 3 in, 3 cubed minus 2 times 3 squared. And I'm not doing any of this mentally. It is just to type it into your calculator. Do it accurately, and then you won't need to redo it again. Things to spot. A little surprising that there are 3 4s that popped up, but it is a cubic, so that's not that surprising. But as we do plot it, let's expect or know what to expect. A cubic often has that style of shape, so if I don't get that style of shape, I know I've done something wrong. Negative 2 to negative 6, negative 1 to negative 4, negative a half, negative 1 to positive 4, negative a half to 4.875, that's going to be around there-ish. 0 to 4, I can already see some of this S shape turning up. 1 is at 0, 1.5 is at negative 1.6, which is about there. 2 is at negative 2, and 3 is at 4. So that is giving me the shape that I want, so now I just need to smoothly try and join it all up. Something like that. Of course, you'll be able to do it a lot easier with pencil and paper than I can with a pen on an iPad. But that was the shape I was expecting. Nothing looks obviously wrong, so I'm happy to move on. Oh, the question isn't over though. Join a suitable line on the graph, find estimates of the solution. So this is our trick. We're going to do curve minus equation equals draw this. So the curve that we sketched was x cubed, or y equals x cubed minus 2x squared minus 3x plus 4. The equation, I'm going to line up the equal signs and line up everything else. Minus x plus 1. And if I subtract these, it'll tell me what I need to draw. So y take away 0, just y. X cubed cancel, x squareds cancel. That's minus 2x plus 3. So I'm going to try and draw the line y equals minus 2x plus 3. Easiest way to draw a straight line is a tiny table of values with just 2 coordinates. Using x is 0, y would just be 3. I could choose x to be 1, but I want to separate them slightly. So I'm going to choose x to be 2, y is negative 1. So 0, 3, and 2, negative 1. 0, 3, and 2, -1. Now I want to try and join these up. Again, you'll be able to do this a lot easier with pencil, ruler on paper. Give your solutions to one decimal place. I think there are 4 solutions that are coming out, and I'm getting solutions of, that's about -0.85. -0.85. That's not 5. What's that solution there? That's about 0.45 and 2.25. Oops. 0.45 and 2.25. They will give you a bit of leniency. I imagine mine are not great because you can see how bad my attempted sketch was. It does look like my lines are not straight and my curve wobbles a bit. So I might be on the boundary of what the mark scheme would allow. Question 15, a bounds question. As soon as you realise it's a bounds question, often because the words in the question say bound, first thing I like to do is to find the upper and lower bounds of each. So for E, the lower bound and the upper bound pretty much break into the next decimal place and put a 5 there. And for F, the lower bound and the upper bound. That gets you your first mark. Depends on this question, maybe it doesn't. But here we want the lower bound of E minus F. But if I want to make this small, I want to use the lower bound of E, but I want to subtract off the upper bound of F. If I want to make that really small, I take the small thing, 8.305, and subtract off the big thing. And calculator says 7.65. And if you did just subtract those two to start with before doing the bounds, you would be getting 7.66, quite a tiny bit bigger. So this being our lower bound is smaller. Question 16. A weird way to do a proportionality question, considering they've given us the graph for it, still going to do the same steps. So it's proportional to t squared. R is proportional to t squared. We replace the fish symbol with equals k, and now we want to sub in a value of r and a value of t. This is where the graph's going to come in. So I'm going to try and pick a point which is perfect. And it looks like that point there lines perfectly up with those two values. So that's t is 2, r is 10. Of course, I could have chosen any coordinate, but the more obvious that it is on a grid square, the more accurate you will be. So subbing that in, the r is 10, k times 2 squared, so the k is 2.5. The question wants a formula linking them, so we need to go back to the r and the t with no extra letters. So basically gone back to that stage there, but replace the k. I do have to have the r and the t in there and not 10 equals 2.5 times 2 squared. That's not a formula, that's just a statement. Given also r is that thing, show that t is inversely proportional to root x. Okay, so now we have a formula for r and a formula for r in terms of t, which was our 2.5 t squared, and a formula for r in terms of x. So we want to link t and x, so let's link t and x. I'm also going to now write, because the rest of it is in fractions, I'm going to write the 2.5 as 5 over 2 equals 8 over 5x. We want to show that t is, so I want to rearrange to make t equals, so that's 16 over 25x, and if I square root, that's 4 over 5 root x, which the 4 over 5 is just some number. So that simply means t is proportional to 1 over root x as the question required. So that whole 4 over 5 is just a number, so I've absorbed it all into the constant of proportionality. And yes, t is exactly the shape we wanted. Question 17. A differentiation question. So first step is just do the derivative. So let's differentiate this. The rule being bring down the power, reduce the power by 1. The next, bring down the 2. If there's a number in the way, you just multiply them. Now the power reduces to a 1, but we don't write power 1. For the next one, we have a hidden power 1. The 1 comes down in front, so it doesn't change. It multiplies by 1. The power reduces to a power of 0, which makes that x disappear. And then finally, a number on its own. If you differentiate that, it just disappears. So you get that quadratic there. C is the curve with the equation that we've just differentiated. Work out the range of values for which C has a negative gradient. Well, that's exactly what the derivative is talking about. It's talking about gradients. So this expression that we've just found, if we want that to have a negative gradient, we want that to be less than 0. And actually, this question is therefore a quadratic inequality. My preference is often to factorize, and to factorize using the kind of the magic method. The 3x squared has to be a 3x and an x. A 15 could be a 1 and 15, but a 3 and a 5 makes more sense. If I wanted to make a negative 4, I could have negative 9x plus 5x to make that negative 4. Factorize in whichever way you feel more comfortable with. So we have our critical values of negative 5 over 3 and 3. Now we need to pick out the inequality that works. So a quick sketch of the quadratic. As so, we have that bit over there being negative 5/3 and that being 3. We want it to be negative, so we're looking at the part of the curve that's under the axis. So my solution is then going to be between the values of negative 5/3 and 3. And moving on. Question 18. Surprisingly little written for this. Triangle has sides of length 8, 10 and 14. Work out the size of the largest angle. I always like to have a picture. If in doubt, draw a picture. So you've got a picture here. This side can be my 8, that can be my 10. This is the longest side, is my 14. And now because I've got a picture, it's a bit more obvious which the largest angle is. It's the one up here. Pretty much the largest angle is opposite the largest side. So this is the angle that I'm going to work out. And now again, because I've got the picture, it should be fairly clear that it's the cosine rule that I should be using. So the cosine rule states a squared. Now let's quote it the right way around. B squared plus c squared minus a squared all over 2bc. You can either memorize that form of rearrangement or rearrange it yourself, or sub the numbers into the normal version given at the front of the book and then rearrange it afterwards. All of which have their own difficulties. If you've got the space to memorize something, I think this way is the most consistent. So that's going to be 8 squared plus 10 squared minus 14 squared. Of course, this side here is the A with the capital A over there, over 2 times 8 times 10. So that's negative a fifth. It's okay, cos is allowed to be negative. It's not often, but it just means that the angle that comes out is actually obtuse. So if cos is negative, you get an obtuse answer. So giving your answer to one decimal place, that's 101.5. And you can now also be completely convinced that that was the largest angle. If they only add up to 180, then you can't have an angle bigger than 101 if you've already got 101 in there. Staying with the theme of trig, now it looks like we've got a 3D trig question. We have a triangular prism. AF is 10, AB is 24, BC is 8. FAB is a right angle, so it's just saying this is a right-angled triangular prism. And BCD is also a right angle. Oh, lots of angles, right angles. So it's got a rectangular base and its front side is a right angle triangle. Work out the angle between the line BE and ABCD. So that's the angle between this line here and the base. If you're ever looking for an angle between a line and a plane, the point that's not on the plane, you need to drop directly down to the base so that you hit it at a right angle and then join that point with the other. So the triangle that we're actually going to care about is the triangle BDE. Now in BDE, we know DE is 10, but that's the only thing we currently know. So let's try and work out a different angle, a different side. And probably the easiest is by using the triangle ADB. Good exam technique, draw out the triangle that you're using. It makes it very obvious to anyone looking at your work, particularly your examiner, to work out what you are doing and therefore give you the marks a lot quicker. So I've already started the working. It is just Pythagoras. So the 8 squared plus the 24 squared, and then we're going to square root that answer. I am going to leave my current working exact, even though 8 root 10 isn't particularly pleasant, so I don't lose accuracy later. I'm now going to use that triangle already mentioned, the DEB. We already knew DE was 10, and we've now worked out that BD is 8 root 10, and the angle we want is the angle down there on the picture, which is the angle here. Well, that's going to be a tan, so tan of the angle is the opposite over the adjacent. Tan inverse of 10 over 8 root 10 gives me an angle of 21.568. Question wants it to one decimal place. That's 21.6. Question 20, a histogram question. We have the birth weight of some babies. 6 of the babies weigh less than 2.5 or greater than 4. So less than 2.5, so that's this section here, or greater than 4. Okay, so you've got 6 babies in those regions. Work out the number of babies between 2.5 and 4. Okay, this question lends itself quite nicely to a box counting method. We do not know the scale over here, and what the information we've been given is quite obscure shapes. They're 2 separate rectangles. So I can't even find this scale point here very easily because they're 2 different heights. So I'm going to do a box counting. So from 2 to 2.5, that's got a base of 5 and a height of 4. There are 20 boxes here, and there are another 10 boxes over there. So in total, I have 30 boxes, and that, we've been told, is 6 babies. So every box is worth a fifth of a baby, 0.2 babies. Okay, but I didn't want this region, I wanted all the others. So let's count all the boxes in all the other regions. That area there is a 5 times a 4 again. The next has a base of 4 and a height of 5, 10, 15, 20. So that's 80 boxes. Next have a base of 2, height of 25. That's 50 boxes. Next is 4 by 15, which is 60 boxes. So from 2.5 to 4, we have 20 plus 80 plus 50 plus 60, 210 boxes, which if we times that by 0.2, the conversion between boxes and babies, times 0.2, that gives us 42 babies in the region that the question wanted. Box counting is not always the best way to go, and often is quite tough to spot whether it is the best or not. But you can see here just how effective it was and how efficient it was on a question like this. And we didn't even need to find the frequency density scale at all. Question 21, surds. Show that. Show you're working clearly. Now you could write root 45 plus root 20 in your calculator and get no marks despite you getting 5 root 5. So because the question is worded as it is, we're going to have to show our working clearly. Way we simplify a surd is by finding a square factor. 45 is 9 times 5. The 9 turns into a 3. And then the root 20 we can write as root 5, root 4, the root 4 turning into a 2. So root 45 plus root 20 is 3 root 5 plus 2 root 5, which gives us the 5 root 5 as required. If you're doing a show that question, you pretty much don't want to use your calculator, and when you do, it can only be for a tiny little step. So you can check that 45 is 9 times 5, or the root of 9 is 3, but you don't want to be typing root 45 into your calculator, because you'll lose that middle step and therefore lose some of the marks. Next question is a rationalise. So we're going to start with what's given. To rationalise, we multiply the top and the bottom by the conjugate, the same thing but with the sign flipped. On the top it's just a simple bracket, so 2 lots of the root 3 and 2 lots of the 1. The bottom is slightly more complicated. Root 3 times root 3 is 3. We're getting a plus root 3 and a minus root 3 and a minus 1. So that's 2 root 3 plus 2 over 2. The 2's all cancel, so we're left with root 3 plus 1. The p is 1 and the q is 3. It does indeed match the form that the question wanted. And finally, express that in the form. Okay, so this is incredibly unpleasant actually. This is a complete the square, but with surds involved as well. So our normal complete the square method, we halve the thing in front of the x. The 6 root 2 turns into a 3 root 2. Put it in a bracket squared, and then we subtract the thing we just wrote squared. We subtract off the 3 root 2 squared. Again, this is show you're working clearly, so I can't just type that in my calculator. I'm going to do it a bit slower. 3 root 2 times 3 root 2 will be 9 from the 3 times 3, and a 2 from the root 2 times root 2, minus 1. And that is then minus 18 minus 19. Only 2 marks there. It's only worth 2 marks, but they're quite a tough 2 marks. Moving to question 22. Instinct is circle theorems, but as soon as we see distances, that kind of should mean we start thinking not about circle theorems, but more about intersecting chords. So the problem is we have a chord here, but this is not yet a chord. So the first thing I'm going to do is actually make it a chord by making it go all the way. And let's call this point here, I've got A, I do have B, C, D, E, F. Okay. But how is that going to help me? I'm looking for this thing over here, so I could work some things about that. Or maybe I need to do the same trick. Maybe I need to extend this line as well and make 2 sets of intersecting chords. Well, that looks more reasonable because I can use the first set to try and find this length here, which then could potentially find the radius But then if I know the radius, then I know the diameter, so I know that bit, and then everything is known. So I think that's going to end up working. So let's do that. So my first intersecting chord formula, the AF times FB, F is the intersection point, so it's going to be included in everything, is DF times, oh, I've used F twice, haven't I? I did not see the F originally in the middle. So I'll rename that as H. Okay, so that's 7 times 4 equals 2 times whatever this FH is. So FH is 14 by solving that. Okay. Now the whole of FH isn't quite a diameter, but I can say that the diameter is then D to H, which is 16, the 2 plus the 14 we've just worked out. But the diameter is also this GE, which is going to be particularly helpful in a moment. So I do want to label that on somehow. I don't want to just put lots of random things on without making it clear though. So that's 16. Now I think I can do my second intersecting chord, but now it's the external chords. So the second one, the intersection point now is C, so everything has to have a C in it. So AC times BC is going to be equal to GC times EC. Everything must have that intersection point in it. A to C is the 7, the 4 and the 5. So that's 16. BC just 5. GC, oh, this is not pleasant, is 16 plus the X. So I want to get all the way out, times EC, which is just an X. So if I expand, simplify and sort this out, I've got 80 equals 16x plus x squared. It's a quadratic, so let's make it equal to 0. I'm moving the 80 over. Okay, well the question didn't tell me anything about rounding, which probably means this does factorize. To make a 16, I can use a 20 and a 4, and the only way to make that work is to make x plus 20 and x minus 4, which gives me solutions of x equals negative 20 or 4, both of which are solutions to the quadratic, but x being negative 20, putting a negative side length is not possible. So we're going to reject that one, and we're going to quote x equals 4 as the answer. And of course, looking at the picture, this side being 4 is very, very reasonable. Again, it's not drawn accurately, but it looks close enough. If it came out as negative 4 and positive 20, I wouldn't believe myself by putting a 20 up there, and I'll probably expect there to have been an error somewhere. And moving on. We've got to the end. This is the end of the papers. This is our very last question. And it is a sequences. So we have a formula at the front that will be very helpful in a moment. The sum of the first 48 is 4 times the sum of the first 36. They haven't told us what the first term or the common difference are. So that's going to make this question really quite awkward. Let's try and translate that first paragraph into anything useful. It's saying the sum of the first 48 is 4 times the sum of the first 36. But we have a formula for this S48 thing and this S36. It's the n over 2, 2a plus n minus 1 d. And I've done the 48 minus 1 straight away there. And that's going to be equal to 4 lots of the new n, which is now 36, over 2, 2a plus n minus 1, this time is 35d. Okay, well, I'm still not particularly happy because this has 2 unknowns. and it's only one equation. All I can do is try and simplify. So let's simplify. That's 24, 2a plus 47d. 4 times 36 over 2 is 72. 2a plus 35d. I'm going to expand everything out. 48a. My only hope at the moment is I can put the a's and the d's all on the same side and something magical happens. But I don't think anything magical can happen. At least not with the information we currently have. Let's move everything to the same side. So subtract, so 144, subtract the 48a's, 96a. There surely is some kind of common factor going on here. 1392d. Common factor of those, is 16 a common factor? It is. So I'm going to try dividing by 16 to start with. 96 by 16 is just 6a plus 87d. One's even, one's odd, so there's no more even factors, but they both look like they're multiples of 3. So that's 2a plus 29d. And now I'm stuck. There's absolutely nothing else I can do with that. I could potentially make a equal, but that's not going to help out. So that first paragraph is done. There's nothing more I can do with the question. So my only hope is now to actually try and answer the question and hope something magical happens. So the question wanted S30. Well, S30 is going to be 30 over 2, 2a plus 30 minus 1d, which simplifies to 15, 2a plus 29d. But this is the magic now. 2a plus 29d is 0. So that bracket is 0. 15 times 0, so sine of, not sine of 30. S30 is just 0. This question is quite famous. This is a fabulously well-designed question, but exceptionally difficult if you don't know what you're aiming for. And there has to be quite a lot of blind faith that the question will do what it needs to do without knowing why or how it's going to pop in. That is the end of the paper, however. If you have spotted any errors, please do let me know. Otherwise, I hope that was quite helpful.